Today we're going to learn how to solve literal equations. Before we do anything, I just want you to know that we're not learning anything that we already don't know. We're just taking everything that we've done with multi-step equations and applying them to equations that don't really have any numbers and are primarily filled with variables. So if you look at these two examples, we're going to take an equation and we're going to solve for one letter in particular, like x, and we're going to have some combination of variables on the other side of the equation. Very different from what we're used to doing, which is just solving for a variable and finding out the value that makes the equation a true statement. I encourage you to pause this slide to review the process if you need to. We're going to talk about these things as we go through the examples. Example number 1. Solve P equals IRT for T. And before we begin, I want to remind you of this idea of PEMDAS backwards, which is SAD-MEP, meaning in order to isolate T, we're going to have to eliminate the variables that are connected to it. And what we're going to do is we're going to look for, is there anything added or being added or subtracted to it that we can eliminate first, because those tend to be the easiest thing. Then we're going to look to see, well, is there anything that's being divided or multiplied? And we're going to eliminate that with inverse operations. Then we're going to see if there's any exponents that we need to eliminate. And finally, we're going to eliminate the parentheses, or what's in the parentheses, last. So our example, P equals IRT. And what we're trying to do is we're trying to isolate T, so we've got to eliminate I and R. We've got to eliminate I and R. And before we can eliminate them, we've got to figure out what the operation is between them and T. And clearly, since there's no operating signs to begin with, I just put the multiplication in. They're being multiplied. So if I want to eliminate something that's being multiplied, I know that I'm going to have to divide. And I can actually divide by I and R in one move because they're both being multiplied. If I divide one side by IR, I've got to make sure I do the same exact thing to the other side to keep the equation equal. Now I'm just going to simplify both sides. Well, P divided by IR can't really be simplified, so I'm just going to write it as P divided by IR equals, I know that I divided by I is 1. I know that R divided by R is 1. And I know that 1 times 1 times T is just T. Now I just want to kind of tell you how you'd put this into the computer if you had to. First, you're just going to write your numerator, which in this case is just P. We're going to use a backslash, and I'm going to put this in alphabetical order, IR. And it was already in alphabetical order, but if it wasn't, you'd have to commute the I in front of the R. The computer's only going to read things if they're alphabetical order. Example number 2. A equals A plus B plus C, all divided by 3. And what we're doing is we're solving for B. So we've got to eliminate everything else. I'm just going to rewrite this right here. A plus B plus C, all divided by 3. Because all 3 of these terms are being divided by the same value, I'm going to put these in parentheses. This is going to help me when I'm trying to figure out what I'm doing first. Because parentheses are last, I'm going to eliminate this division. Inverse of division is multiplication, and what I want to eliminate is 3, so I'm going to multiply by 3. I'm just going to write it as a fraction. Over here, I got to do the same exact thing. I got to multiply by 3. I don't have to write it as a fraction because A isn't a fraction. Now I'm just going to simplify. 3 times A is the same thing as 3A equals, and 3 divided by 3 is a cross division right here, is just 1. And A plus B plus C divided by 1 is just A plus B plus C. I can drop the parentheses now. Now I've got to eliminate A and I've got to eliminate C because I want to isolate B. So I'm going to use inverse operations here. Since A is being added to B, I'm going to do the inverse of addition, which is subtraction, and I'm going to subtract by what I'm trying to eliminate, which is just A. If I subtract A from one side, I've got to subtract A from the other side. I can't fit it in here, so I'm going to write it as addition of a negative, which adding a negative and subtracting are the same exact thing, so I hope that doesn't confuse you. When I simplify my left side, I've got negative a plus 3a. Now these aren't like terms, even though they're the same variable, same letter. One of them's lowercase, one of them's capital. Okay, we can't combine them unless they're the exact same variable written the exact same way. On my right side, I'm left with just b plus c because a minus a eliminates to 0. So here I have b plus c. Now I've got to eliminate c. Since c is also being added, I know that if I subtract, which is the inverse of addition, a c, then these two will be eliminated. I've got to also make sure that I do the same exact thing to the other side, so I'm going to add a negative again. Now I know that b equals, and now I'm going to write b on this side. And now I know that b equals, I'm going to write b on this left side now, negative c plus a negative. I can just condense this double sign to minus a plus 3a. And when I put this into the equation, I've got to make sure that I put it in alphabetical order. And since a and a come in the same sequence in the alphabet, I'm going to write my capital A first. So I need to commute this term to the front, and a comes before, or sorry, negative a comes before c, so I'm going to commute that right in behind the negative c, and I can write that as 3a, it's positive still is, minus a, negative still is, minus c. Okay, our third example, t minus yc equals b, and we're solving for c. So I have a t minus yc equals b, and what we're trying to do is isolate c, so we've got to eliminate this negative y and this t. Because this t is being subtracted, or technically added to this c, in order to eliminate it, since it's positive, if I add the opposite, which is a negative t, I know that those will go to 0 when we simplify. Well, if I add a negative t on one side, I've got to make sure I do the exact same thing on the other side. Adding a negative again is the same thing as subtracting. I know that negative t plus t is 0, so what I'm left with is a negative y times c equals b minus t. Now my last step is to eliminate this negative y. Since the negative y is being multiplied to the c, I'm going to use division, which is the inverse, and I'm going to divide by what I want to eliminate. I've got to make sure that I do the same exact thing to the entire side. Now I can rewrite my equation. After I simplify negative y divided by negative y, I just have c equals b minus t divided by y, and I'm actually going to write this negative out in front, and I'm going to put b and this minus t in parentheses because they're both being divided by the y. And if I do that and I type that in just like this with a negative parentheses b minus t parentheses slash divided by y, the computer should read this because it's in alphabetical order, and I'm making sure to include parentheses for my order of operations. Here we have example number 4, v equals pi times r squared times h. And I'm solving for h, so I've got to eliminate r squared and pi. Well, pi is being multiplied to the h, and r squared is also being multiplied by the h. There's not an operating sign, but we know when there's not an operating sign, that's multiplication. Since they're both being multiplied, I know that I'm going to divide. If I want to get rid of the pi, I'm going to divide by pi. If I want to eliminate the r squared, I'm going to divide by r squared. If I divide one side by pi r squared, I've got to make sure that I do the exact same thing to the other side. Now I can simplify my sides. Pi divided by pi is 1. 1 times r squared divided by r squared is 1 times h is just h, and v divided by pi r squared is just v divided by pi r squared. Now I'm going to show you how to put this into the computer. I'm going to start with my numerator. Since there's only one term in the numerator, I don't have to put it in parentheses. Backslash pi r. I've got to use that little caret, and I can just write it as 2. Example number 5. Negative 50 minus 10y equals 6x, and we're solving for y. So we've got to eliminate these things that are connected to it. Well, this negative 10 is being multiplied to the y, and this negative 50 is being added. So if I want to eliminate, I'm going to start with this negative 50 since it's being added. I'm going to add a 50 because if I add the opposite of a negative 50, I know that when I simplify these, they will eliminate each other. If I add 50 to one side, I've got to make sure I add it to the other. Here is 50 plus a negative 50, which is just 0. I'm left with negative 10y equals 6x plus 50. Now I've got to eliminate this negative 10. I know that it's being multiplied to this y, even though there's not an operating sign. I can put a little dot if I have to. I'm going to divide to get rid of the multiplication, and I'm going to divide by negative 10 to get rid of the negative 10 that's being multiplied. I've got to make sure that I also divide the other side by the same exact value, and I'm going to divide this one individually this time to both of the terms because I know that one of these terms is going to be able to be simplified, and I've got to simplify the equation if I can. Negative 10 divided by negative 10 is just 1 times y is just y equals 6x divided by negative 10 is just 6x divided by 10, and I'm going to write this negative out in front like this, plus 50 divided by negative 10. Well, I know that a positive divided by a negative is a negative, and 50 divided by 10 is 5. When I type this into my answer bar, I'm going to type it in as negative 6x divided by 10 minus 5, and I don't need to include any parentheses here. Here we have example 6. C equals 5/9 multiplied by f minus 32. And if I rewrite this out here, I'm going to rewrite it with my right side now on my left just because I can. So I'm going to write this as 5/9 times f minus 32 equals C. Now if I'm using reverse PEMDAS, I'm going to save my parentheses for the last thing that I'm going to eliminate, and I'm going to focus on this 5/9. Because I know that this 5/9 is being multiplied, I'm going to eliminate this before I have to distribute it, because distributing this would just create more work for me, and I don't want more work. In order to eliminate a fraction that's being multiplied, all you have to do is multiply by the reciprocal, which in this case is just 9 divided by 5. If I multiply 9 divided by 5, or 9 over 5 on one side, I've got to make sure I do the exact same thing on the other side. I'm going to turn this C into a fraction by just dividing it by 1. Now I'm going to simplify. 9 divided by 9 is 1, times 5 divided by 5 is 1, times f minus 32 is just f minus 32, which is what we wanted. C times 9 is 9c, and 1 times 5 is just 5. Now I've got to eliminate this negative 32. Since it's connected through subtraction, I know that I'm going to add 32, or I'm just going to add the opposite of a 32, which is I'm going to add the opposite of a negative 32, which is a positive 32. If I add 32 to one side, I've got to add 32 to the other side. Now I'm going to simplify. These are going to simplify to 0. I'm left with f equals, these aren't like terms, I can't combine them, so I'm going to write my answer as 9c divided by 5 plus 32, and I can type this into my answer bar like this: 9c divided by 5 plus 32